All right, back to talk about origin of mountains. So mountains' official definition are elevated parts of Earth's crust rising abruptly above the surrounding surface. So really just tall things above the Earth's surface. They are created by the folding and the faulting of the crust. There are three basic origins, folding or faulting, and then also volcanic activity. These are all pictures of mountains. You have isolated mountains here on the left, chains of mountains on the right to image, which are based on the different formation types. So domed mountains are going to be the first kind we'll talk about, which is down here in the pretty green image at the bottom left-hand side. These are broad arching folds. Over time, the sharp features of the mountains will get worn away, and it leaves more resistant granite peaks that then get covered with really pretty life like this. But they're very broad sloping mountains. They're not very tall and jagged like the mountains we saw on the other side that are just jagged points, look very sharp. They're going to be a little bit more smooth. Fault block mountains are our horse and grabens. So when we talked about the rocks pulling apart and how sometimes the spots will fall down and get pushed up, these are fault block mountains. They're going to rise sharply and steeply along inclined fault planes, and then over time the weathering will erode those sharp corners to create kind of a rolling mountainous valley like the Sierra Nevadas and things like that. The domed mountains are more like the Black Hill Mountains in South Dakota. Now, volcanoes are also a source. A volcanic mountain is produced because of a volcano, which is a hill or mountain formed over time by the extrusions of lava or rock fragments from the magma below. It has some pretty features, the vent, the crater, and the lava flow. Some examples are the Cascade Mountains, which are dormant, mostly dormant or I would say inactive volcanoes. There's one in Hawaii, and those are the two main ones that I can think of as two examples. The one here on the bottom right is one of the Cascade Mountains. I think it's Mount St. Helens, and they tend to be snowy capped up in the Cascades, the Pacific Northwest, but they tend to not exist in chains. Like the fault block and the domed mountains will exist in chains of mountains, several tall peaks at a time, whereas the volcanic mountains are going to be kind of isolated peaks. So we talked about the building up, so now let's talk about the wearing down of Earth's surface. We're going to talk about weathering. So weathering are slow changes that result in the breakup, crumbling, or other destruction of solid rock. They're going to include physical, chemical, and biological processes. Physical is sometimes called mechanical. The weathering contributes to the rock cycle, which is important, we've talked about in the previous chapter. The formation of our soils, which is important for agricultural and trees and our world as a whole. And weathering also is going to contribute to the movement of rock materials over Earth's surfaces, which we'll talk about. So we're going to call this erosion, the process of physically removing weathered materials. So when a rock gets broken down, it's weathered. It isn't until it gets moved from one place to another that we call it erosion. So for example, what kind of things can weathering produce? Well, this is an image of the Grand Canyon with the Colorado River running through it. At one point, the Colorado River would have been tall enough to run through the Grand Canyon as a large flowing river. For a variety of reasons, it's now a trickling stream through the Grand Canyon, but the Grand Canyon was formed due to erosion by an agent called water. So mechanical or physical weathering is going to be the physical breakup of rocks without changing their chemical nature. So no chemical change occurs. It's a disintegration process. One of the examples is wedging. So on the upper left-hand image and the bottom right-hand image, upper right-hand and lower right-hand image, you have tree roots growing up, which are, in this case, one is breaking a sidewalk, which is not a natural rock, it's a man-made rock. But in the bottom right-hand image, you have a tree root coming up and breaking a rock apart. Now another example is frost. And so in the image on the bottom left, you have a rock with water that has seeped in, and then once that water freezes, it will expand and it'll crack the rock, And over time, eventually that piece of the rock will fall off. And that's also a type of wedging, but it's done by frost and not by trees. The image on the middle, kind of bottom left, right next to the wedging by frost, is called exfoliation. And so this is where you have just kind of pieces of the rock coming off, like it has multiple layers of an onion. And that's called exfoliation, just like if you were to exfoliate your skin. Shed off the old and reveal the new. Chemical weathering, on the other hand, is going to be decomposition of minerals by chemical reactions. Three kinds that we're going to talk about are oxidation, carbonation, and hydration. So oxidation on the right upper left-hand image, the really red nature of the rock you see here is due to oxidation of iron minerals. Something we're very familiar here with in East Texas because we have a lot of iron ore, so we're familiar with the red color. On the bottom left, we have an example of carbonation, and so this is sometimes due to acidic rain or acidic ocean, but often what happens is you get these really neat features of like holes or caverns being carved out inside the rock. This same type of process is what produces our beautiful caverns. Texas has a cavern system down in New Braunfels that's really, really wonderful, and you can go there and tour the caverns. They're very specific about the number of people that can go down there and touching the walls because of contamination and because it's a water source. And so, but it's a really wonderful thing to see. This was water flowing underground that carved out these really beautiful features, which is chemical weathering. The third kind is hydration, which is essentially a rock being dissolved by water. I don't have an example of one here specifically, but it's really just water dissolving a rock like it would salt or sugar or another soluble material. So now we're going to talk about erosion. So erosion is really mass movement, and we have different types of mass movement caused by gravity. Remember, gravity is always bringing us down from a place of high to a place of low. So creep is going to be the slow movement of soil down a steep slope. So for example, this tree might be over time slowly moved down from its higher point to its lower point. Whereas a landslide is going to be any slow to rapid downhill movement of materials. So the image down here on the bottom right is an example of a rapid downhill movement of materials. There were houses above this structure, and they very quickly slid down in a landslide, muddy, sometimes water, excess rain contributes to this. Sometimes it's unstable underground support that you can't see until you start to have the signs of a landslide occurring. So running water is the most important gravitational erosion process. So if you look here, we have the Grand Canyon, where we talked about that's how it's formed. But here we have a very murky, muddy river. And the reason why the river is muddy and murky is because it contains a lot of weathered materials. And this river is transporting those weathered materials downstream. That's all rivers run downstream. So the stream bed is going to evolve over time, and we call this stream development. So when we have what we call a youthful stream, the landmass is recently uplifted, there's a steep gradient, the valleys are a V shape with no floodplain, lots of boulders, rapids, waterfalls. Over time, the stream gradient is going to be smooth and lowered down, so we lose those sharp, distinct mountain features. The V-shaped valleys become more like U-shapes. There are meanders over the floodplain, so a little bit bigger, not as fast-flowing rivers, more slow-moving. And once we have a stream that's considered old age, very low gradient, meaning no steep hills, no steep mountains, broad, gently sloping valleys, and then there's going to be a sluggish flow, and the area is going to be more likely to flood if we have a heavy rainfall, because there's nowhere. The top two images kind of act like funnels, funneling the water downhill, whereas in the last one we lose that funnel and the water is going to be more stagnant and not flow as fast. So what happens when these rivers reach the ocean? Well, they form a delta. And a delta is a deposit of sediment at the mouth of a river or a stream. The stream flow will dissipate into an ocean or lake. The most famous one we have is probably the Mississippi Delta. And we have stream flow dissipating these erosive and sedimentary, or these sedimentary minerals. But what happens is the stream itself loses its ability to keep carrying the materials, so they basically just get dropped off. The stream is kind of like a bulldozer, and then once it reaches the ocean, it just kind of dumps its load of sediment out, and then it continues and continues and continues until you have a big pile of sediment that's been carried down the stream. Now, deltas have a really unique ecosystem because of some of the features of the sediment, which has a lot of nutrients. It attracts a lot of life. It's very unique. So the Mississippi River depositing out in New Orleans is a delta area, very pretty. You see an image here of a delta, so you can kind of see the streams coming out, and then the darker areas are where the sediment is higher, built up a lot more, and then the lighter areas in the image under the water are going to be where they're a little bit deeper, but very murky as it transitions out to fresh salt water. So now we'll talk about glaciers. Glaciers are masses of ice on land that move just due to their own weight. So because of gravity, but because they're so heavy. So glaciers have formed from snow accumulated over many years, anywhere from 5 to 3,500 years. We have two different types of glaciers based on where they're found. So an alpine glacier is formed at a high elevation, so think your mountains, and they're going to flow through the valleys. Sometimes they're called valley glaciers as well, but alpine should help you think mountains, which should help you think elevation. The other type are continental glaciers, and these are going to be glaciers that cover a large area of a continent, and we only have two examples, Greenland and Antarctica. So the interesting thing about Greenland is it's covered in ice, and Iceland is green, but in Greenland we have a continental glacier, and then as well as Antarctica, the continent is a continental glacier. Okay, so those are the two differences. One originates up in a mountain, and the other one, it covers a large area of continent or land. So this ends chapter 16 and about Earth's surfaces. And when you're ready, make sure you submit your